advanced functions. So this is a lecture about development. So we talk about development in the lecture about JavaScript, another lecture about multi-file importing, and this is the third lecture on development. And this is the advanced function. So we'll talk about some function syntax, first-class functions, higher-order functions, callbacks, a lot of things. What are they? So let's go through them one by one. So on the left-hand side, method 1 is how we are defining functions now. Like we define a function called sum. We take two parameters, a and b, and we return a sum of a and b. So this is how we are defining functions now. However, in JavaScript, there are other ways to define a function, which are method 2 and method 3. So let's have a look at method 2 first. So in method 2, like when you select const sum, what comes to your mind? Like, it's like we are defining a variable, right? So it's like when we define, like for example, const sum equal to 2 or const sum equal to 3, like that, or const sum equal to string called sum. But here, const sum equal to a function. So this is like a more modern way of using like function syntax in JavaScript. There's another way, like method 3, we remove the function keyword. However, we kind of add this arrow in between of the input parameters and the bracket. So they are the same. So method 1, 2, 3, they are the same. So all of them are about defining a function, the different function syntax here. It's fun, like using method 1 or 2 or 3, they are both, all of them are correct. But we'll show some examples, and you will see like method 2 and method 3, they are very useful. Okay, have some like advantages. And in TypeScript, they are the same. Like when we talk about TypeScript, we mentioned that when we run TypeScript, like at the back, it compiled into JavaScript and run the JavaScript file. So like how we define functions in TypeScript is the same. The only difference is that we have the types defined. Right. Cool. So let me show you this one. So sometimes, like when in our function, there's only one line in the body. So for example, this one, in the body of this function, we only have one line, which is return a plus b. Okay. In this case, when there's only one line in the body of function, we can remove the bracket and also the return keyword. So the function becomes constant sum, a and b, and then the arrow a plus b. So a plus b is the only thing is done in this sum function. So there's only one line in this function. So we can directly have a plus b after the arrow. So very short, right? It's quite condensed. Another example. So let's open this example in the code. For .1 many strings. For .1 many strings. Okay, so this is the way like we define functions previously. So now how can we change this to a like method 2 or method 3? What is the first step? Remove this function keyword. Yep, const many string equal to, and then this arrow like this. Okay, so this is how we change from method 1 to method 3. So we cannot skip method 2, right? Make sense? Yeah, it's just different syntax. Okay, so this is just what we just did. Okay, move from the original way of defining function to the method array. Okay, so now we have seen how we define a function similar to how we define a variable. Yep, question.
You said masses.
Method array. What is method array? So you kind of missed a couple of slides. So this is method array. So different syntax for defining functions. So we move from, we start from the original, the way we are defining functions now, to a more modern way of defining a function, like defining a variable, similar to defining a variable. So this is the method array. All good? Oops. Okay, now you've seen how we define a function like we define a variable. So now we have, on the left-hand side of our definition, we have constant name and the value to this name. And then on the right-hand side, how we define a function, it's very similar, like const and get name, and followed by the function. So get name is a function. And in this get name function, it returns COMP1531. Actually, the function, the one on the right-hand side, can be more condensed. You know how? Do you know how we can make it more condensed? Yes, that's right. Because we only have one line in the body of the function. So we can remove the return keyword and also the bracket. Okay. So one language that allows us to define a function like defining a variable, we call this programming language allows first-class functions. So first-class functions are language that has treat functions just like another variable. So we define, we declare the function very similar to how we define, declare a variable. And we can also use it very similar to how we use variable. And we will see some examples. Yep. Okay, so let's have a look at this example. This is format. So this is the code we have. Okay. So we have a couple of functions. First one is bracket, full stop. So bracket takes in a string and add bracket to it, return the string with a bracket added. And for full stop, we take a string and return a string with full stop at the end, like this. Okay. And now we also have another function called say hi. Okay, and in this say hi, you may notice that the variable, the parameters we give say hi, has a name and also a format. What is this format? So format is a function of this type. A little bit confusing now, right? So this is a TypeScript file, right? So in TypeScript, we can define aliases for tabs. So we can define our own tabs. Remember, when we talk about TypeScript, and we define the tab called format string, and this tab is like a function. For this tab, we take a string and returns a string. Yeah, a little bit tricky here. So here we define the type as an alias, right, when we talk about TypeScript. And this is a tab that we define. It's called format string, like FMTR. And this is a tab that we define for a function. So in JavaScript, we can treat functions like variables. Like variables have type. Right? Functions, we can also define a type for the functions. So we treat functions like variables. Take some time to digest, right? Questions? Yep.
Really, how do they work?
How do they work?
Yes.
Okay, so let me show you how do they work. So now I'm passing in a function called format, and it's of a format string type. Now we can call. So we are passing in this function like any other variables. Okay, so before we explain more, let's try to run this code and see how it works, and we'll go back to the code. So we are in the red folder. Do you remember how to run TS code, TypeScript code? npm, npm run ts node, right? And the file name is in this source code folder, and file name is profile1 fcf format atomic.ts. So this is, I'll make it a bit larger. So in this code, we want to console log the result, and the result is say hi, like we call it say hi function. And say hi function has two parameters. One is name, which is a string, and then functions is passed in to this say hi function. So we use function like a variable, okay, as a parameter for say hi function. And for the first part, like say hi COMP1531 bracket, we got hello COMP1531 bracket. And for the second part, like we can have say hi COMP1531 full stop, like hello COMP1531 full stop. So we use function like a variable and pass into the function as a parameter. Yep. Yeah, when you first get into this concept, it may be a little bit confusing, but you get used to it, like when you practice more on that. Yeah. From the questions asked during the break, I can see that you are quite struggle to understand what is happening here. Some common questions asked during the lecture break. Okay, first one is, what exactly is that? Here we when we in the very first week when we talk about JavaScript, we mentioned that everything we can think of everything in JavaScript as an object. So what does an object has? Like object has properties like the values. Object also have functions or method. And for like the string or number, we can think of them like only have the property with value, but do not have a function or method, right? For the functions, we can think of it as another type of object. So we can also call it function object that only have function, but do not have property or values, right? If that is easier for you. So we can also call it function object. So you can treat the function as an object or as a variable, right? So for other variables, like we can define the type, for example, whether it's a string or whether it's a number, and we can do the same for function objects. And this is how we define the function objects type. So what are the type in a function that you think we need to define? Like we need to define the type for the parameters, right? And we also define the type that has been returned, that return values type. So this is basically the parameters type and the return values type. Okay, so why do we need this? So why do we need to define this type? Okay, so the reason that we need to define this type is because when we want to pass in a function as a parameter for example, say hi, like when we want to pass in a parameter, and this parameter is a function, we need to define its type, right? So it's similar, like when you want to pass in a parameter, for example, name, you need to define its type, like whether it's a string, whether it's a number, or what is it. So it is the same with function, we also need to declare what type is it. Yeah, question?
What if we don't know what type we want to return?
Any. So there's a tab in TypeScript. The last tab like we talk about in TypeScript is any. Remember that when we do not know what type is it, we use any temporarily, but we do not encourage using any, right? Cool. Okay. Another question.
What do we put for objects? Like if we're returning an object, we just put like the big square brackets or something else.
Sorry, what's your question?
What do we put if we know we're going to return an object, but we don't know what's in it?
What if we know we are returning an object, but we do not know what is in it? So when we define an object tab, so this was in last lecture. So when we know it's okay. So when we define an object tab, there are required tabs and optional tabs. So there should at least be one tab defined in that object, and others can be optional, but there should be at least one required tab. So we should know that. Yep. Cool. Okay, so what is say hi here? What is this line? So in say hi, we pass in two parameters, which are name and the format. Okay, and the name is clear that it's of type string, but format here is of this type. So we need to pass in a function of this type. Yeah. So what will happen if we have we want to pass in, for example, brackets here, but we define number tab, and we pass in brackets here as a second parameter of say hi? What will happen? A tab error. Right. So this is the same like when we have a function called say hi and parameters are name of string and number of number, and you pass in a number and a string. So it will be an error, like tab error. So if we pass in a function of non-FMTR tab, there will also be a tab error message. Okay. So what does say hi function do? Like what say hi function does? So say hi function takes in a string. So when we call it, like we takes in a COMP1531 a string. Okay, and we return hello format name. So format is a function, can be like brackets or full stop, and we return either add brackets to name or either full stop for name. Yeah. Any question? It's absolutely fine if you are confused here, so you just feel free to ask. Yeah, question?
So the type FMTR, you're declaring it as a function, right? So because of that, you have to pass in these functions into that parameter.
What?
Because the format of FMTR is you're declaring FMTR as like a function, essentially.
A function tab. So it's a tab. So FMTR is a tab. It's not a function.
Oh, it's just a function type.
Yes, it's a tab.
And so because of that, you're just passing in functions to that parameter.
We are not passing anything into FMTR. It's a tab. So we cannot pass in anything to it. It's not a function. We can only pass in parameters into a function. Yeah, if it makes sense.
Yeah, so I'm saying that for the brackets and the full stop function, that's why you're passing it into the second parameter instead of just passing in strings.
Did you mean this function here and this function?
Yeah.
Like they only have one parameter for each, which is a string.
I'll just explain that after.
Okay, sure, no problem. A question from online: why do you not have curly braces in line 15? Okay, this is a very good question. So why don't we have like bracket braces after brackets and also full stop? So actually here, just a I don't want to make it too complex, but actually here we are using callback functions. So using function in function is called callbacks. And for callback functions, we cannot use parentheses after the function name. Yeah, so it's just a syntax when we use callbacks. Okay, cool. I hope that answers your question. Yeah, just do not want to make it too complex. But what we are actually doing here is called callback functions. Means that using function in functions is called callbacks. And for callback functions, the syntax requires us to not include that parentheses, like do not include the braces. Only have the function name here. Yeah. Cool. Okay, so now this is the file that we have. Can anyone help me make it better, like by using methods array, like make it more condensed? Any brave hands? Or you can help me, like you? Yep.
For the brackets and full stop function, we can make it one line function.
Make it one line function. Yes, exactly. Const, oops, brackets equals to, and then like that, and we return like this. And the same with the full stop. Yep. We can have const full stop equals to, oops, like this. Because we only have one line in the body of the function, so we can make it one line, right? Yep. Anything else? Do the same to say hi. Yep. Const say hi equals to hello. Yep. Anything else? Oh, here's an error. Anything else? I think maybe that's all. Yep. So you can see how condensed is it. Like it's much easier to rate using methods array. Yep. Question.
I think we can omit the yellow parentheses for brackets and full stop.
Omit the yellow brackets here.
Yeah, and also remove the type. Remove the string as well.
Yep.
Not that one.
Like that.
Yeah, but we would have to delete the string, like str colon string. We can delete that because like oh, they can't tell.
So which one?
I was wrong.
Yeah, I was a little bit confused. Not sure if we can do this, but for JavaScript we can do that. For example, we can have like string and then the error and then what is returned. For JavaScript is fine, but I'm really not sure if we can do this for TypeScript.
I think we can do that, but we have to specify the type of full stop.
Yeah. Yep. Maybe. Yep. As long as it's still easy to rate and not adding extra like complexity. Yep. Cool. So this is how we use functions in methods array. Yep. Cool. Yeah, that's it. Ooh. So here's something more about first class functions. Some more examples, like how we use functions in a loop. Actually, I think they are the same. Like, they are not really more complicated. We are still passing in a parameter, which is a function, and use this function within a loop. So nothing new. You just make it use in a like longer code, like more code, but it's the same. The concept is the same. Any question? Yeah, cool. Yeah, it's the same. It's the same. Maybe we can use that as an example. Yep, so this is the original one. Not not much we can do actually. Oh, okay. Cool. So it's basically the same. Nothing new. Like we still define a function called bracket, and we pass in the function bracket into this format name function, and we loop through all the names like Simia, Jonathan, Sally, and we format the name in this loop. Okay. Yep. I don't think question. Yep. Yes, that's a good question, and we'll explain Mac very soon. Yep, later in the lecture. So this file, like this function, actually can be easier, and we'll explain how very soon. Okay. Otherwise, okay. First-class functions are predominantly used in terms of lighting functions taking another function as an argument. So as what we have seen, using functions as a parameter in a function and pass that function into a function. So using functions in a function. Yeah. So it can allow us to create more concise and more clear code. And in particular, the use of anonymous function. Oh, anonymous function is just what we did with, like when we only have one line in the body of function, we can omit the return keyword and the bracket. So this is called I think I might have missed something. Yes, this is the one that I've missed. Okay, format loop. New. Okay, so let's have another look at this function. Sorry about that. So now we define the function called brackets and add brackets to the value, like for example, add brackets to Samia, add brackets to Jonathan, add brackets to Sally in this format names function. So let's run that. Okay, so this is the function called format loop new. So you can see that we add brackets to all of them, like all the names in the names array. Okay. However, you may have noticed that we only use the brackets once, right? So here's the only place like we pass in brackets into this format name function, right? And we refer it to format in this format name function here. So this is the only line like we use brackets. So can we, a good practice in like when we write in code is when we declared a variable but we only use that once, maybe we do not need to declare that variable, right? We can use the value of that variable directly. So this is the same for functions. So if we declare a function but we only use it once, maybe we do not need to define that function, right? Maybe we can just use the value of that function directly. So this is what we call anonymous function. So we do not need to give this function a name. Like we can just use the function directly, like how we use the value of a variable directly before, right? So what we can do here is when we use the brackets here, like this is the only case we use brackets, like when we pass it into format name, we can directly have string returns a string with brackets. Right, so we do not need to declare this brackets function here, but we can use it directly as what it is, like what brackets does. Right, it's like we pass in format name names 3, right? Passing the value of a variable directly. Okay, so this is called anonymous function. Yep. That's all. Okay, now let's move on. Okay, so some more advanced functions that we can use. all of these are about arrays. So we talk about array methods like array.push, array.less, and these are like array.map, array.reduce, and array.filter. So they also work on our arrays. Okay, what do they do actually? So what is map, what is filter, and what is reduce? Before we explain how we use them, let's have a quick look at what they do. Can you see my screen? Yep. Okay, so now imagine that we have an array with some dots. For example, we have some shorter dots like this. We also have some longer dots like that. Okay, with map, like for example, array.map, we want them, all of them, change somehow. Like for example, we want all of them to change to blue. Like we still have 5 dots, like this, but the color changed. So the property of them changed. So this is map. So change the value in that array. So this is map. What is the other one? Reduce. Well, let's try filter first. So what is filter? So for example, I do not need to change the value, but I want to get some of them. For example, I only want to get like the shorter dots. Okay, so this is filter. And what about reduce? Oops, reduce. Sorry about my handwriting. So reduce is condense the array into one single value. So for example, the sum of the values in that array. Okay, so it will be like like this. So how do we reduce the array? We can define the function. So this is the sum. We can also have define a function called average. It will be the average length of the dots. So somehow like that. Okay, and we also have what others? But you can define what you want to do with reduce. But it needs to return one single value to it, like after we reduce that array. So this is actually what we want this map, reduce, or filter to do. Now let's explain how they map and filter and reduce. How do we use them? So let's have a look at map first. So we take an array of size n, okay, and produce a new array of exactly size n, but modify the elements according to a function that pass in. So same array size, like where we changed from the red color dots into blue color dots. The size is the same, but the value changed. We modified it. Okay, so this is the classical way, the way we can do before we know anything about mapping. Okay, so now we have constitutors. So these are our admins for 1531, and we short to them and make all of them to uppercase and add this at the end. And now we create a new list, an empty new list, and we loop through the tutor in this tutor's array. And for each of them, we call this short function. Right? And we modify the value of the tutor one by one. So this is the classical way, right? We used before. So now here's another way that we can use map. Okay. Again, we have defined an array with the tutors, and then we define a function called short. Okay, that's the same. However, now we do not have this loop. We do not start with an empty array called new list, and we do not loop through every element in this array, but we use map, like tutors.map, and the function that we call here is short. Again, we are passing in a function as a parameter into this map function. So again, we are using function in a function, right? So, okay, so let's try this out. 4.1 map. Yep, so you can see that all of them becomes uppercase, and we are shorting to them. Yep, so this is what we have here. Again, we can also make it more condensed. For example, we can have remove this function, add this arrow, remove that, and that. Okay, so it's very, very condensed, especially comparing with our original like classical version, like looping through the array. Right? Okay. Yep. So that is map. Now filter. Filter takes an array of size n and produce a new array of size less than n. So we get some of them, maybe all of them, maybe 0 of them. But we do not want to modify any of the value, the value of any components in that array. Elements unchanged. So how do we use that? So let's have a look at the example in the classical version. We start with max, and we have a function called isPass. If the mark is greater than 50, then we push that to this new list. So we loop through all the mark in this max array. isPass, we push to the new list. Okay, so this is the classical version. However, there's another more modern version. Again, we define this isPass function. However, we directly use max.filter. Right. For maps, we use the tutor.map and the short function. And here we use max.filter and the isPass function. So we define the function, the criteria that we want to use for either map or filter. Okay, so let's quickly run filters. Oops, filter. Is it filters? Filter. Oh no, filter. Okay, so only the values that is greater than 50 is returned. Okay. So this is filter. Okay, so now we are coming to reduce. Remember, reduce needs to return one single value. Either is we can define how we want the single value to be. We can get the sum of all the values in the array. We can get the average of the values in the array. We define it. Okay, but it needs to return one single value. Okay, so let's have a look at this example again. We have max. Okay, we start with a single, and we loop through all the values in this max, and we get a sum, the sum of the max. Okay, so this is the conventional way. And now the modern way. Again, we have the max, okay, in the array, and all of them are of type number. Okay. Now we define our function, how we want to reduce the number, or how we want to reduce the array to one single number. We want to get a sum. Okay, so this is the function that we define. We have a previous and a current. And this is how we use reduce. Okay, so sum, 0. What are they? So sum we know is the function that we defined here. But what is this 0? 0 is the starting point, the initial value of that single output. So remember that when we talk about reduce, we want to return one single number, one single value, right? And the initial value of that returned is 0. And the function we want to use here is the sum. So what is previous and current here? Let me try to draw something. I bring my iPad today. Okay. Oops, I cannot see. This is 55. No. So ashamed of my handwriting. I'll stop writing on it. So what we are actually doing here is that we start with 0, okay, and then we get and when we call this sum, the previous number in the first run would be 0, and the current number is 55. Okay, after this very first run, the previous number turns to 55, current number becomes 43. In another go, the previous number becomes 98, and the current number becomes 34. So it's actually the same what is actually happening here. But the difference is more condensed. I'm not sure if I have explained clearly. How should I explain that? Sorry? Oh, I thought you have a question. Okay. Filter. So, not filter, it's reduce. Reduce. Okay, so this is what we have here. So what is happening behind this max.reduce is that we take, so the previous initially is 0, okay, in the first one, and the current is 55. Okay, after the very first go, the previous becomes 55, the current becomes 43, and then in another go it becomes 98, and the current becomes 34, and like that. So this is reduce. But we can also define different functions. So maybe we have average here, we can also have minus here, we can have previous minus current, we can also have plus. Like we can define how we want to reduce it. So we define our own function. Yeah, question?
What are the reduce method? What are the, like for the two parameters, what are they meant for?
What are the?
Like for the reduce method, like what
Yep.
are the parameters like come like meant for? Because I think one is meant for the function, the other one is meant for a number.
So we want to act on this max array. So given an array which is max, we want to make change to like use this max array and returns a single. Right. So this is same with map. Like we also take some max array, and we map the value in that array and return another new array. But here we return a single value, and the action we do on it is some function that we defined. And the initial value like start with 0, but we can also change that. For example, start from 9. Will be the first go will be previous will be 9, and current will be 55, and this will be 64, and etc. Still.
I'll ask about that later.
Okay, sure, no problem. Okay, so I found a very fine summary of filter, reduce, and filter online on Twitter. So this is one like what map, filter, and reduce they do. So for example, map, we start from coins, and then after we cook them, they become popcorns, hamburger, and pan-fried eggs. And we filter it like whether it's vegetarian, and this is what we got. And we eat them. So yeah, it's a fun one. Cool. Oops, not this one. So for all of them, like we can use anonymous functions to further streamline our previous code. For example, this one we can have remove this and just return previous with current. So this can be very condensed, right? So this is the same with all the examples we have seen before. Another example like its path, we can also use like that. Oops. I need to. Am I doing something wrong here? Oh, I need to remove this function. Yes. Yes. Okay. So with this anonymous function can be very powerful. And its path we only use once, so we can just put them here like that. Okay. So you can see how condensed is it. Like it's very powerful. And the same with the reduce. Okay, we can have, because sum is only used once, we can remove that, put it here. I will add a bracket to it. Okay, and then I remove this sum function. Right, so it's very, very condensed. Sometimes you may find that you are striving to condense your code. This might be good, might be not good. The principle that you need to follow is to make sure that your code is easy to read. So if you put too much effort on like condensing the code, and then it becomes very hard to read, it might not be like a good practice. Cool. So here's another example, like we combine map, filter, and reduce in one single example. So we want to print the average mark of those students who passed the 60-mark exam, express the average in a percentage. So here are the marks, and we normalize those marks. Given at m, we want to return a normalized value of m. Okay, and then we filter the marks, like, and find those who passed the 50 marks. So we given m, we want to return all the m's that is greater than 50, and then we reduce them. Like we add the sum of the the sum of the marks that is greater than 50, and then we calculate the average. So in only 6 lines, we are actually doing quite a lot, right? Callback, very briefly. So callback is a function passed as an argument into another function, like using function in a function. It's called callback. Okay. Higher order functions. So higher order functions are essentially functions that return functions. So we have seen examples like passing functions into functions. Well, here we are going to see some like return functions. So here in this example, oops. So this is what we have originally, and let's try to clean that up. Okay. Congrats your mark, like whether it's pass, whether it's credit, or whether it's distinction. So we kind of define 3 functions here, right? And you may think that you are repeating quite a lot. For example, we repeat calculations 1, 2, 3, like 3 times. We are repeating congratulations in these 3 functions. We are also repeating the names in these 3 functions. So is there any way like we can make it more abstract without all of this repetition? So this is like we can have like a helper function called congrat wrapper. So it's like a helper function, and then we can use this congrats wrapper in this like mark pass, mark the CR, or mark distinction, and we use this wrapper function, and then we define like whether it should be a pass, whether it's a credit, or whether it's distinction, and then we console log. Okay, so we can take it a bit further. So in this one, although we abstract it without all the repetition, but we are still using method 1 when defining functions. We can use like the method 3, like const function name, and then the arrow followed by the function body. like step by step. Is my code so funny? Yeah? Okay, that's nice to know. Cool. So let's take it a little bit further than that. Like we define another function called generate concrete marks. Okay, in this function, we define another function, basically. So we are like less repetition, more abstract, but sometimes, like for now you may find like, what is it? Like I think it's harder to read than the previous one. So it's normal because you just get to know the advanced functions lecture. But when you are more familiar with the methods array and passing functions in functions, you will find like the abstract way is more, like it's easier to read. Yeah. Step by step, and this is what we end up with. Actually, I think, like personally, I think this eventually the very last version is not the best one in all of these versions, because you may see like return, what are they? So actually we are return a function here, right? But sometimes it can be a little bit confusing. So as I mentioned before, make sure your code is easy to read will be your first principle. So if you are abstracting too much, condensing too much, sometimes it can be harder to read. Right? So why you are condensing the code? Why you are abstracting code? Because you want it to easy to read, right? Yep. So higher order functions, kind of slick ways to generalize function definitions. Well, today's lecture may still be a little bit confusing for some of you. It makes sense. It will take time for you to get familiar or comfortable with how we write functions in this new way. Well, for now, just no particular lab that will help you practice writing like advanced functions, that we don't have a dedicated lab for that. But you can try to write advanced functions in your future lab, but it's not a requirement. This lecture will be kind of a support lecture. So you will not be like directly assessed, like having assessment on this lecture. But for the following lectures, some of the code will need this knowledge to understand the future lectures. So it's kind of more of a support lecture. So if you are a little bit confused, don't need to be too worried about that. It will take time to really understand what we are doing here. And you will be more and more comfortable with that. Otherwise, that's all for today. Oh, and also, this lecture will also be not relevant to you till next week. Yep, so iteration 1 will be your main focus for now. Yep, cool. Thank you, everyone. Thank you. Thank you.